Hello, in this video, we will look at class templates. We presented a class for stack of integers. In the stack of integer class, we put integers into the stack. So here, the data type for pick is to return an integer. For push is to push an integer into the stack. Pop is to remove the integer at the top of the stack and return the removed value. Internally, we store all the elements in an array. Now, using templates, we can revise the stack to store any type of values, not just integer. It can be double, string, character, or any other objects. So let's look at this diagram. What we need to do is now to have this generic type T. The element type is T now. With the pick return, the value type is T. Push, the value type is T. Pop to remove and return, the removed value type is T. This is the implementation for the template class. It is template. And this is type name is T. Class stack. Boolean is this is the empty is const. This is the pick, push, pop, and this is the elements in the array. So now we are going to this is the header file. So I put the header file and with the implementation in all one file. And the reason we're doing this is in the early compilers, if you separate the header file and the implementation file for templates, and some compilers may not be able to handle it. So I'm just going to put them all together. So this is template. Type name T, and this is the constructor in the stack class. Initialize the size to 0. This is to implement push. Push, this is the value, the type is T. So that's all the implementation for this stack of T type. So this is the generic stack of T type. Let's write a test program for this. We're going to test the generic stack. Is you're going to create a stack here. Now, this is the place you're going to specify the concrete type to replace the generic type T. So stack of integer, we're going to push it's int stack dot push I into the stack. Now we're going to remove items out of the stack. So this is int stack empty. If it's not empty, so we're going to remove it. And now we create another stack. This is the string stack. Push Chicago, Denver, and I'm going to push London into this stack. Now we're going to remove the elements out of the stack, string stack, empty. If not is empty, we're going to remove one. Now let's write this sample here. Test generic stack with template functions. We have this template type name T. So here I'm going to have this stack T. And here it's passed by reference. Now this is going to be a problem. You cannot pass this. You cannot have this as const. So this is going to be a problem. So when you print this, if you do pass by reference, and because you cannot have the constant, it's changed inside. So what you have to do here is you have just to pass by value. So to ensure that when you print stack int stack, the contents of int stack after the call remains the same. So inside when you call it, because you're going to pop it, so we're going to pass, in this case, pass by value. And here for the stack of strings, and we have all this, Chicago, Denver, London. So we're going to invoke print stack, string stack, pass by value. So please note, if you pass by reference, see what happens after this call is finished, your stack, string stack is going to be empty. So don't do it and use pass by value. So in this situation, pass by value makes sense. You can use the default type for the generic. So here is the type name, T is int. So when you create a stack without specifying the concrete type for generic type, T, so by default, that is int. And you can also have this, the non type parameter. So this is not a type. This is the type. Types T. So here you can have this capacity here. So this is the stack. So now when you create a stack, you have this concrete type string, and also you can specify the capacity. So this is fine. You can also have multiple generic types when you define a class. That is all for class templates. Thank you for watching. See you on the next video.